Okay, so these were the answers to 14 and 15. So take a look, see how you did. And we're going to move on to 9-7, the cross product. All right, so in 9-5, we talked about one type of product of vectors. And in 9-7, we talk about a different product that is used for different things. Okay, when we did the dot product, when you take the dot product of two vectors, you just get a number, right? But when you take the cross product, you're actually going to get another vector. All right. So here is how we do it. There's not going to be a ton of examples today. Okay, you just need to know how to do this, how to find the cross product. So example. I'm going to say the first vector is 2i plus 3j plus 5k. And the second one is I plus 2j plus 3k. Part A. Find the cross product of between v and w. So when we do dot product, it's v dot w. When we do cross product, it looks like the old-fashioned times symbol, v times w. Okay, so you know which product they're talking about. And here is how we do it. We are going to set up a 3x3 determinant. So just like we just did. And in the top row, we are going to put our variables I, j, k. In the next row, we're going to put the coefficients of one of the vectors, the first one, that is, 2, 3, 5. And on the bottom, coefficients of the other vector, 1, 2, 3. And now that we know how to use the expansion by minors method, that is what we're going to do here. Okay, so we take the I, I guess I'll write my work, 3, 5, 2, 3, minus j, that'd be 2, 5, 1, 3, plus k, and that'd be 2, 3, 1, 2. Okay, so we've got I times 9 minus 10 minus j, which is multiplied by 6 minus 5, plus k, which is multiplied by 4 minus 3. All right, so that means that's negative 1 there, so we've got negative I. That's 1 times j with a minus in front, minus j, and 1 times k is plus k. Negative I minus j plus k. All right, so that is how we do the cross product. Okay, we'll talk a little bit later about one application and one thing we can use the cross product for, but let's go ahead and do this. Okay, we know when we did the dot product, it was commutative, which meant when we flipped it around, it was the same answer. We're going to test if that is true with the cross product. So it would be ijk, but now we'll flip around the rows and put the 1, 2, 3 here. Oops. And the 2, 3, 5 here. Okay, so I'm going to skip right to, got I, and then I know that I would multiply that by these 4 numbers, 2 times 5 minus 3 times 3, so that'd be 10 minus 9. Minus j, that'd be these 4, so 1, 3, 2, 5, so that'd be 1 times 5 minus 3 times 2, plus k, 1, 2, 2, 3, so 1 times 3 is 3 minus 4. So is the cross product commutative? The answer to that is yes or no. No. It's the opposite instead, right? Signs were all flipped around from what we got up here. All right, that will always happen when you do the cross products. Okay, part C. This last one, example for this example, is find the cross product between the vector and itself. Okay, so when I do this one, got ijk. V is 2, 3, 5, so I'm going to do 2, 3, 5, 2, 3, 5. All right, so we'll go through the math on this one. That would be I times 15 minus 15 minus j, as you see what's going to happen here, 10 minus 10 plus k, 6 minus 6, and so they all cancel out, and the answer is 0. So the cross product between a vector and itself is always 0. What you will see about today's assignment, and you don't have to, I'll just show you quick in the book about what's going to happen for a lot of how they're going to set up most of the problems. I'm looking at page 631 here. Check this out. So there's a few of these problems first where you just do the determinants like we've been doing. And then it gets to this section. It says, in problems 15 through 22, find the cross product of V and W, the cross product of W and V, the cross product of W and W, and the cross product of V and V, which is kind of silly, right? Because really, you only have to do the work for the first one, right? You'll do the work for that one. Then for this one, you'll flip the signs. This one, this one, 0, right? So C and D will be 0 for all of them. So just make sure somehow you note that on your assignment so that if I ask on a notebook check, what's the answer to number 20, part D, you can say 0. All right? And then they'll have some more random stuff with different vectors that you'll be doing on the next page. All right, so just a few more things then. On the notes here. Here, I gave you properties before. Properties of the cross product. We did this with the dot product. So, obviously one of them is that, and if we say vector u crossed with vector u, of course we're always going to say 0. If we've got the cross product between u and v, that's always equal to negative of the cross product between v and u. So those are two that you just saw. If you've got some number So that's just a scalar, any scalar that's multiplied in front of a cross product, you can split it up like this. Which property is that in the old-fashioned algebra properties? Remember? Associative, when you just move the parentheses around but you don't change the order. So they're saying the associative property works for this, and then I could also, it would also be equal to this. I could split it around like that as well. Let's see. The old-fashioned distributive property works here. So if you've got the cross product between vector u and the sum of vectors v and w, you could split it up like this. So these properties we're writing down just in case you come across something like these. You could simplify it this way. You can go straight to these properties. Okay, this next one is important regarding your assignment. The cross product of u and v is orthogonal to both u and v. Okay, so when you've got vectors u and v, and you do the cross product of them, the vector that you get as the answer is orthogonal to u, and it's orthogonal. It's perpendicular to both of those vectors. All right? And another thing is the cross product is equal to 0 if and only if they are parallel. So if you do the cross product and you get an answer of 0, then those vectors must have been parallel. And then lastly, the magnitude of the cross product between u and v is the area of a parallelogram, okay, with u and v as adjacent sides. Okay, so the old-fashioned area of a parallelogram formula in a two-dimensional parallelogram, base times height. These are vectors in 3 variables, so it's like parallelogram in space. The area can be found with the cross product, and that's we're going to have a couple problems that deal with that. So here are the last 2 examples I really need to talk about. One of them, they will ask you this: find a vector orthogonal to, and then they will give you 2 vectors. Let's say it's 3i minus 2j plus k for u. And let's say v is negative I plus 3j minus k. What would we do if we have a problem like this, given the properties that you wrote down above this? We'll just do the cross product. Okay, so I'm just going to write that down. I'm not even going to do this problem. I'm just writing it as a note so you know what to do. Do the cross product and you'll have the answer. Okay, so if they just ask you for an orthogonal vector, that just means do the cross product and you'll get the answer. Okay, and then the other example that we need to take a look at one of these before you do it is find the area of a parallelogram. So we'll do an example of this. going to find the area of a parallelogram, and these are the vertices. P1 is the point 0, 0, 0. P2 is the point 3, negative 2, 1. P3 is negative 1, 3, negative 1. And P4 is 2, 1, 0. All right, so I'm just going to draw my parallelogram like this instead of trying to draw it, as a 3D figure. Because all we really need to do is know, if I label that P1, we'll call that P2, P3, P4. Doesn't really matter if it's drawn correctly. All that matters is, what is the vector that goes from P1 to P2? What is the vector that goes from P1 to P3, and so on? And we know how to do that from yesterday. The vector that goes from P1 to P2, we could look up here and write the vector. We go from 0 to 3, so that's 3i. We go from 0 to negative 2, so that's minus 2j, and we go from 0 to 1, so that's plus k. All right, say we want to go from P1 to P3. We went from 0 to negative 1. Okay, so that's negative I. We went from 0 to 3, so that's plus 3j. 0 to negative 1 is minus k. I could go ahead and fill in the other sides as well, but really you only need 2 of them. Okay, because it says above, to find the area of a parallelogram, we do the magnitude of the cross product of u and v is the area of a parallelogram where u and v are adjacent sides. Okay? That means sides next to each other. So I've got 2 sides adjacent right here. So if I do the cross product of those 2 vectors that I just wrote and take the magnitude of that will be the area of this parallelogram. Okay? So let's go ahead and do that. I, j, k. And then put one of the vectors here, 3, negative 2, 1. Put the other vector here, negative 1, 3, negative 1. And if you're thinking to yourself, wait, how do I know which one to put in the, in the second row and which one to put in the third? Because you get a different cross product, right, when you, depending on where you put them. But once you do the magnitude, it's not going to matter, right? Because we will square the numbers, and so it doesn't matter whether they're the negative of each other. So it doesn't matter which one you put where. All right, we just need to do the math here. So we'll do I times, careful with the signs here, that's 2 minus 3, minus j, negative 3 plus 1, plus k, 9 minus 2. So now I've got negative I, that's negative 2 times negative j, so plus 2j, 9 minus 2 is 7, plus 7k. So there's the cross product vector, negative I plus 2j plus 7k. Now I do the magnitude of that, which is the square root of the sums of the squares. So that'd be 1 plus 4 plus 49. That'd be 5 plus 49 is the square root of 54, which we could write as 9 times 6 is 54, so 3 radical 6. So I guess I would call this the area of a parallelogram, so 3 radical 6 square units. Okay, so that is how you will find the area of a parallelogram. in space like this. All right, that is really all we need to talk about here, so you should be able to do the assignment, which is the odds. Page 631, 7 to 35 odd, and then 41 to 47 odd. All right. Thanks for tuning in.